So let's solve some problems now that involve using Ohm's law, as well as the conclusions that we just drew about how voltage and current behave in series and parallel circuits. These are the example problems from your class note. So for question number 1, it asks, if the current in the following circuit is 20 amps, determine the voltage drop across each resistor. So in this example, you are given that there's a current in this circuit, and that current is 20 amps. Sometimes it's useful to label things right on a diagram before you start the grasp method. The other thing I want to notice right away is, what type of circuit is this? Because there's only one path for the current to travel, and because all of the loads are connected side by side, this is a series circuit. So that means you automatically have to think about the relationships we just found concerning voltage and current in a series circuit. So I'm going to get started now with the grasp method. So the first thing I'm going to do for the grasp method is write down what I'm given. I'm given that the current in the circuit is 20 amps. I'm given the first resistance is 20 ohms. The second resistance is 50 ohms. And the third resistance is 30 ohms. I'm asked to find what is V1, then what is V2, then what is V3. And I'm going to have to use what I know about series circuits to figure this out. The equation that we're going to use, please stay put. The equation that we're going to use is Ohm's law, V equals I times R. We're just going to use that one equation. And if we take a look, it's already in the format that I want. I know current, I know resistance, I want to calculate V, so I don't even have to rearrange. In a problem like this, it's okay to have multiple steps in your solutions part of the analysis. So it's okay that we're going to break the solution step up into 3 separate components. The first thing I need to know to solve this problem is I need to recognize, because this is a series circuit, the current is the same at every point in the circuit. That means that the current through resistor 1 is the same as the current through resistor 2, which is the same as the current through resistor 3, which we are already given in the question, 20 amps. So that makes our lives a little bit easier. Now, in terms of our solution, V1 is equal to I1 times R1. That's using Ohm's law, but applying it just to resistor 1 first. So V1 is equal to 20 amps times the resistance of resistor 1, which is 20 ohms. 20 times 20 is 400, so it's very high voltage. So 400 volts. And notice how I'm going to just write 4 digits, 400, because I'm going to match the number of digits that were displayed in my original answer. So V1 is 400 volts. V2, I'm going to do the same thing. I'm going to apply Ohm's law, but this time to resistance 2. V2 is equal to the current through resistor 2, again 20 amps, times the resistance of resistor 2, which is 50 ohms. In this case, V2 is 1,000 volts, very high voltage. Finally, I'm going to apply Ohm's law to resistor 3. In this case, the current through resistor 3 is again 20 amps. This time, the resistance is 30 ohms. So this comes out to 600 volts. The very last step in my grasp method, to paraphrase. So I'll say, therefore, the voltage across R1 is 400 volts. Across R2, it's 1,000 volts. That's a V. Let me just, there we go, fix that. 1,000 volts. And across R3, it's 600 volts. So that's the end of that question. I've broken down my solution into 3 steps, and I've clearly laid out all the things that I know and the things that I need to find. Last example question for today. Calculate the current through each resistor. I'm not given a lot of information in the question itself, but I am given some information in the diagram. I'm given 2 resistors, R1 30 ohms, R2 20 ohms. And I have to identify right off the bat that this is connected in parallel. This is the total resistance. I'm going to call that VT. The voltage, the total voltage supplied by my source is 9 volts. If I were to trace the current, I would have a current here. I'm going to call it IT, the current through the battery. It's going to reach this part of my circuit and it's going to split. Part of that current is going to go through resistor 1, which I will call I1. And the rest of that current is going to go through resistor 2, I'll call that I2. When these 2 currents meet up, they're going to meet up here. They're going to travel back to the battery with that same current, IT. So that's one of the rules I'm going to keep in mind when I solve this problem. I'm going to go ahead and start my grasp method. So I'm going to list the things that I know. I know that the voltage of the source is 9 volts. I know R1 is 30 ohms. And I know R2 is 20 ohms. I would like to find the current through I1, and I would like to find the current through I2. In this case, I'm going to write down the equation that I'm going to use. V equals I times R. I would like to find I in this case. That's what I'd like to rearrange for. So in this step, in this analysis step, I'm going to do a really quick rearrange of this equation. Because I want to isolate I, I'm going to divide both sides by R. So R divided by R is just 1. I'm left with V over R equals I. Now I've got I all by itself, which is exactly what I want when I solve this problem. Next step, solve. I'm going to have to apply Ohm's law, and I'm going to have to use one of the rules about parallel circuits. And the rule that I'm going to use is the fact that the voltage across each load in parallel is the same as the voltage across the source. I'm going to write that down here once it lets me right at the bottom. There we go. The voltage across the source is the same as the voltage across resistor 1, which is the same as the voltage across resistor 2. I'm given that voltage in the question. It's 9 volts. So I'm going to write that down. Now I'm going to apply Ohm's law for both resistors. For resistor number 1, I1 equals V1 over R1. We just said voltage across resistor 1 is 9 volts, whereas the resistance of resistor 1 was 30 ohms. Dividing those two numbers gives me a current of 0.30 amps. And notice how I'm rounding so that I try to match the same number of digits that's displayed in my original numbers. Now on to resistor number 2. I2 is equal to V2 over R2. In this case, the voltage across resistor 2 we already determined is 9 volts, and the resistance is 20 ohms. You don't need to put the units in at this step. That's totally optional. When I calculate that, I get a current through resistor 2 of 0.45 amps. So I've answered my original question. The only thing left to do is paraphrase. Therefore, the current through R1 is 0.30 amps, and through R2, it's 0.45